Hi, everyone. Welcome to Math 70, lecture on section 2.5. This is all about linear equations using a different form, which is called standard form. But first, a bit of review. You are going to encounter standard form sometimes, but whenever you can, I recommend that you work in slope-intercept form because it's what we use the most often. Y equals mx plus b, where m is the slope and b is the y-intercept. And if you have a line graphed like this, then you can figure out the formula for the line by looking at the slope. So if it goes over 3 and up 1, the slope is 1/3. Rise over run, or change in y over change in x. And then you can just read off the y-intercept as being at the point 2. And so your line would have the formula y equals 1/3 x plus 2. So I recommend slope-intercept form when you can, but sometimes you're going to find you're working with standard form instead. But let me introduce standard form to you with a couple of different examples. The standard form for lines might look something like 3x plus 2y equals 50, for example. And so what you get is you get the x and y's on the same side, and they're each multiplied by a number. Instead of having y by itself, you have y is probably multiplied by a number, so is the x, and they're on the same side. This is still a straight line, but it's in a different form. So when working with this form, my recommendation is to convert to slope-intercept form. And the way you do that is by solving for y. So in this case, if I have 3x plus 2y equals 50, I'm going to solve for y. So first I'll subtract 3x from both sides. And I get 2y equals negative 3x plus 50. I could have written it as 50 minus 3x, but if we're going for slope-intercept form, let's get the x and then the intercept. And it's 2y, so the y doesn't have anything else on its side, but it is still multiplied by the 2, so I divide each term by 2, and I get y equals negative 3/2 x plus 50 over 2 is 25. And now I have it in slope-intercept form. And now I can use my slope-intercept tools to use that equation however I want. That's my recommendation. If you're given standard form in symbols and you need to work with it, go ahead and convert it to slope-intercept form. What if you're asked to graph an equation that is written in standard form? So for example, let's look at, let's see, 4y minus 8x equals 12. I don't have to have the x's first. In this case, the 4y minus 8x, the 4y was first. This is still a linear equation, but it is not written in slope-intercept form. So if we need to graph, we have two options. Option one is convert to slope-intercept form. Again, that's a pretty good idea in general, so let's do that. 4y minus 8x equals 12. I'm solving for y, so I'll add 8x to both sides. And now I have 4y equals 8x plus 12. And I divide both sides by 4. And I get y equals 2x plus 3. And now I can go ahead and I can graph it. My line has a slope of 2 and goes through the point 0, 3. So there it is. There's my line right there. All right, I'm converting something new back into something that I'd worked with before, and that makes my task a little easier. That's option one for graphing. Option two, if I'm asked to graph 4y minus 8x equals 12, I can test a couple points. So I can convert it to a numerical representation first. When you work with lines, numerical representations tend to be really useful. So let's do this. Let's try a couple different x's and y's. So I'm going to try x equals 0 because that's really easy to do that arithmetic compared to other numbers I could pick. So if x equals 0, I have 4y minus 8 times 0 equals 12. Well, the 8 times 0 goes away. I'm left with 4y equals 12, or y, dividing both sides by 4, I get y equals 3. So when x is 0, y is 3. Notice that's exactly the y-intercept. Right there. X is 0, y is 3. So I forgot to write to test 2 points. And those points are x equals 0 and separately y equals 0. So I come over here and I put y equals 0 in. And now I have 4 times 0 minus 8x equals 12. The 4 times 0 goes away. And I have negative 8x equals 12. I divide both sides by the negative 8. And I end up with x equals negative 1.5 or negative 3/2, which is that point right there. Y is 0, x is negative 1.5. Now I have 2 points, and I know that's a straight line because it's a linear equation. And I can connect them, and now I have the exact same graph I had before. Notice how this point goes right through there, which is 0, negative 1.5. So graphing an equation written in standard form, as a recap, one, you can solve for slope-intercept form and then use the intercept and the slope to draw your line. Or two, you can test two reference points, the x-intercept, or let's start with the y-intercept where x is 0, and then the x-intercept where y is 0, and then you get 2 points on your graph and you connect them. Notice that everything I've done so far in this video has really been saying, has been moving away from using this standard form. Oftentimes you'll set up an equation and it'll end up in standard form. But really the next step is to somehow move away from this symbolic representation, either by graphing it or by converting it to slope-intercept form. All right.